It's January 14th, 2020. I'll come at you with a video. Hey, we've had another CME, okay? This one was right in front of the Earth. Now, I cannot tell you if it's Earth directed yet, okay? We got to wait on some more data to come in and to see what direction this thing's moving. But you're looking at it right there. Okay, watch. Boom. See that? See the bright area and watch it explode out. Boom. Okay? So, yeah. And I'm going to say this too. This was not a very large one, but it wasn't small. It's pretty moderate is what I would call it. Now, we can't tell the intensity and the strength of it until it actually starts getting to our detectors to get an exact thing going on with that. We can kind of guess and judge at it by the size of it and what we've looked at before and kind of compare. But I tend not to go ahead and do that anyway. I'll just tell you this, that it would probably looks to be moderate. That's what I would say right now. But anyway, if you remember a couple videos back, I was telling you guys, here's the equator of the sun, and the Earth sits right here. Well, remember the sunspot that was over here? And I was telling you guys, as it rotated through in front of Earth, that we really need to be paying attention to it, because if it had a CME or a solar flare when it was right in front of us, the chances of it hitting us are greater. Okay, and also the chances of CMEs and solar flares happening around an active area or a sunspot is greater anyway. Now, with all that being said, I can't tell you if this thing is going to hit us, and the reason being is because, like I said, the Earth's over here. CME was here. This CME could have blew that way, that way, that way, this way, okay? It doesn't necessarily have to come right at us. Now, but what I will say, the chances of it actually at least giving us a glancing blow is greater because we're cutting off some of those angles. If this was to happen over here, it could actually blow over towards us and still miss us. So that's what I'm trying to say. So yeah, but we'll let you watch that a couple more times there. Boom. I mean, it's definitely something cool to look at. And again, I've seen way bigger. Okay. When we see these off the side of the sun, we're able to see more things because the background of space gives us a black contrast. Okay. So when we have these things right in front of us, as we're looking at the sun itself kind of camouflages it because of the light of it. Okay. So that is what that does. That's why we see it when it comes off the side a lot better than when it's right in front of us. And that's also one of the reasons why we can't see what direction it's going yet. We have to go look at the other tools, wait for the data to come in. And I tried to go look at the other tools, but the data has not come back on that yet. But again, I can tell you right now, that is a CME. That was a pretty moderate one in my opinion. So what do we need to be looking out for? Well, probably here in about 3 to 4 days, this will probably, if it does come at Earth, it'll impact us then. We might see some upticks in geomagnetic activity, okay? Solar storm levels. Then we got to look at auroras, will probably increase. What else? Earthquakes. Like I said, earthquakes are always an issue with this whenever we have these kinds of things happening. So, and on the high end of it, I guess if this is bigger than what it looks to be, and it hit us right on the chin, I guess we could have some electrical problems or some other issues like that. So, and we'll keep an eye on this, and when I get more data in on this, I'll bring it out to you guys and let you guys see it, and I'll show it to you and give you my opinion on it. But I'm going to take you over to the tracker, the CME tracker. Okay, guys, this is over at planetxnews.org. This is Scott's website, and this is where I go to the tracker. If you guys go down about halfway, you'll see all these links, and these are pretty much all the links that I use, just to let you guys know. I mean, they're all there. It's really easy to go here and click on them. I do have some desktop shortcuts just because it's made it faster for me because I make these videos and stuff. But most people would be okay just coming here because it makes it easy, especially if you're just starting to look at these tools. So what I'm going to show you here, guys, is the CME tracker. Oh, goodness. Let's see here. Where's it at? Sorry about that, guys. But anyway, I want to point this out because I was going out and trying to get some information on this CME that just happened. I was trying to get some captures from different tools and stuff. And really not a whole lot of data's come in for it yet. But this part here is, like I said, is the CME tracker. But this is an old CME. Okay. While I was looking for those captures, I came across the video, and they were saying this thing was mistaken and this wasn't accurate. Well, if you're thinking that this was the CME that just happened, yes, it would be inaccurate. But this is not the CME that just happened. This is the CME that happened back on, I think it was the 6th or 7th or something. Because this tool does not update unless it has another CME. So the second CME I just showed you guys hasn't had enough time to update this graph yet. That's what you're seeing here. This is the old CME. I could actually go back to my video where I showed you guys this, and it's identical. But it's all, and I've made the same mistake, guys. Okay? So the first thing we need to do when we see this stuff is always go look at the timestamp. Okay? Because this was, yeah. So, I just wanted to point that out in case you guys went and looked at the CME tracker yourself. Just know that this is that old CME. And we're going to see another one. This one will update in the next few hours probably, and it'll change it. So, but again, the left one here is top-down view. This is side view. This over here is straight line. But what that's representing is, see the Earth's orbital path around the sun? What they've done is they've taken that circle path right there and stretched it out in a straight line. Just gives us a different visual. It helps us decide direction. This is a two-dimensional model trying to represent a three-dimensional thing. So that's where we got to stop with that, because we can't really get a good sense of depth and stuff like that unless we're looking at different angles, different cuts. Okay? Okay, guys, this is the geomagnetic magnetosphere models. Okay, this is the speed, the velocity there. I'm going to go ahead and start playing these real quick, so I want to show you guys some stuff. But yeah, I'm seeing some crazy looking, I don't want to call them crazy, just stuff that is weird, okay? This is the velocity one. All right, now you're looking at the sun's over here, so that the solar wind should be blowing this way, which is what this is depicting. Okay, now, again, I mean, it just doesn't look right, in my opinion. And the reason why is not so much that this is very, very slow solar wind to begin with. Okay, now, this is the density. Now, the wider the signature here is, the less dense it is. So, you know, on the Australian model, it was actually showing 0, which it's really not 0. Okay, the tool just doesn't go down far enough as far as 0.0001. That means there's still density there. But that tool over there on the Australian model stops at 0.0. It doesn't try to see anything past that. So that's why you would see that. The density's there. There's always going to be stuff there. Now, here, as you can see, though, it's very, very low. And what has kind of got me on this is the duration of how long it's staying like this. Okay, the longer it stays like this, guys, the more stuff that actually can happen. Now, I know that most people think a low number would be great. Well, no, it's not the case. We want to be in the middle. We want to be average. We want to be, you know, right dead smack in the middle. Okay? Got to find that balance right there, because if you don't, then both sides of that will actually cause issues. If it's real strong or high dense material that's hitting Earth's magnetic field, earthquake risks go up. Auroras increase. All that kind of stuff, right? Now, as we're talking about this, when you get low density, and I was thinking about this because, you know, we just had these volcanoes, right? You know, and guys, if you didn't get a chance, go check out some of the volcanic lightning. That was awesome. Some of that stuff was just cool. I mean, it really was. It was awesome. But if you can think of, you know, what are we talking about when we're talking about volcanoes and earthquakes? Well, we're talking about pressure, right? That's what happens. That pressure builds up and it has to release. So, just follow me here. Now, I'm not sure if this is the exact science on this, but this is just how my mind works, so I'm just going to share it with you guys. I could be wrong on this part. I don't know. But in my mind, logically, this kind of plays out to what I'm getting ready to say. So, if you got low pressure, and just say that the Earth's core, or what have you, is got magma and lava and all that stuff we talk about when we're talking about volcanoes, and it starts building pressure, right? Well, what contains that pressure? What keeps it, like I just said, in balance? Well, it would be an equal force pushing the other way, right? So, if the pressure releases around us via no material, like up here, no dense material, the pressure that's inside, in my mind, seems as though it might come on out, right? It had an easier time of actually having eruptions or actually having earthquakes even, okay? All that stuff's tied together. It's just seismic activity, basically. But yeah, I do think that might have something to do with this. As you can see, this is a time lapse, guys. Look, it's not doing nothing. There is no pressure there. So you can see the time lapse moving there. All right, when it switched, yep, see it changed just a little bit. But, you know, I got on here about 5 hours ago and there was nothing there. It was completely blue. There was no contrast of anything there. So that's why I wanted to show you this, because I do think that sometimes when we don't have, you know, the correct amount of pressure pushing on us, we actually will push out and, you know, it can cause some other issues such as volcanoes and earthquakes and stuff like that. That's just how my mind works. Now, I don't know if that's actual the science behind it, and I'm sure that there's something there. I just don't know the specific science that is behind all that. I am trying to learn, and again, I've said this before, when we're talking about earthquakes and volcanoes, I'm learning more and more and more every day, but I'm not comfortable enough saying, hey, this is this way or that way. You know, I would point you over to, you know, like I said, over to Dutch Sense or Scott or somebody like that has had a lot more experience trying to show people this. So, okay, guys, I got you over here at the Schumann, okay, the Schumann resonance. Yeah, I'm noticing some stuff here, and I'm just gonna show you what I'm talking about. Okay, now the first thing when I look at any tool I look at, guys, I try to get in my mind what a normal signature would look like. Okay, and this is not it. Okay. But also, when I'm looking at stuff, I look for symmetry. You know, like in the magnetosphere models I show you guys. Because if it's not happening on the bottom as it's happening on the top, or vice versa, then it means it's directional, right? Well, when we're talking about the Schumann, you know, I'm looking at this and I'm thinking, man, what's going on here? So I start looking at this little spike right here. That happened at 12, right? You go over here, this spike here happened really close to 12. Okay, and then we start looking over here, and it just looks like the duration between them are very, very close. Like it's, I don't know what's going on here is what I'm saying. It looks like it's symmetrical is what I'm trying to say, I guess. But yeah, that's just an observation I made. Maybe that's nothing. It probably isn't nothing. But to have a similar size spike there, well, there and there and there, okay, and for them to be pretty close to the same amount of time in between each spike, we have to stop and look. But again, as you can see, guys, I was talking about, hey, you know, we might be having our base frequency. Maybe we're having more than one base frequency now. And I got a lot of good comments and a lot of good suggestions about what might be going on there. And I'm digging into all that. I'm trying to figure this out myself also. But as you can tell, you know, our base frequency is 7.83, which is here. Well, it seems as though this one here is staying here pretty consistent now. And at least for the past few days, we're picking up even some here and here. Okay. That's just really odd. Now, look at that. That's that one signature I showed you guys yesterday. Okay. Now, again, I'm trying to figure out if this is a tool flaw or not. All right. So I'm actually going into this hoping that it's a tool flaw. Yeah. So I'm actually trying to get, you know, just show myself that this is a tool flaw. And as of right now, I can't say that. And one of the reasons is, if you go over here and you look, well, see, here's that other spike. Look, it's still doing the stripe stuff. All right, now, check this out. Here's this other little spike. Well, what's it doing? It's doing our little dashed line we've been talking about. But that's vertical. The one that we usually talk about is up here. Right in. It's right in here at this level. Okay. It's still there. It's dashing out right there. You see it? But it seems as though we're seeing it in the vertical now too. And I showed that to you guys the other day. Now, again, look over here. See how it's starting to stripe out there? So, in my mind, if this was a tool flaw, that line, like where the line is, like say right here, you follow that through, it should line up with the next spike, right? Well, it's not. Now, I know that wasn't a straight line that just drew there. It's kind of ridiculous. But over here, you can really see it. Okay? I mean, because it's even wider. And that's why I don't think that this possibly could not be a tool flaw. And I know I keep going back to this, guys. You guys can clearly see this bothers me. Because I want to know what this is. And we just can't figure it out yet. So, but I wanted to show that to you, because we're still getting those striped signatures now. Horizontally striped. And look at this. The whole thing there looks like it's horizontal. Look at that. Almost looks like a plaid t-shirt or something. But, yeah. So, okay, guys. I just went back to the SDO here. I wanted to show you guys this. This does look like it might be just a touch bigger than what I thought it was. You can see how it's kind of going out like that. Now, again, I can't tell you direction yet. That's just what it looks like here from what I'm seeing right there. Right about there. Watch. Boom. See how it kind of ripples up the front? See that? Like a little haze. So, yeah. But, yeah, guys. And, yeah. So we'll go ahead and end it there, guys. I'll try to come back with you here in a little while. And maybe give you an update on this and show you guys some more stuff that I've been working on. But, yeah. Just pay attention. Earthquakes, always, guys. Earthquakes, you just got to pay attention to those things. That danger is not going to go away for a while, okay? Especially now that we're seeing volcanoes and stuff. And now we always have volcanoes, but when we have a volcano like happened over there in the Philippines, it shot up 9 miles high in the sky, and was seen from the satellites, which sometimes they are and sometimes they're not. Usually the bigger ones, and it also probably has something to do with the cloud cover and stuff, how well they pick it up. Now, they probably use thermal imaging also, so they can pick it up anyway. But if you guys go look at some of those things, just go check out some of those, that volcanic lightning. It was awesome. But, yeah. So, God bless. Yeshua saves, and you can drink this Kool-Aid.